Hello, in this video I want to look at finding the mean and standard deviation of a probability distribution, but using an alternative approach. Now specifically, this has to deal with like if we know the probability of an outcome is given, that is, like if we have a roll of a die, it's 1/6. If we have a coin, it's 1 out of 2. And then, of course, if we were to say, for example, that 72 people out of 100 that went to, let's say, like a tutoring program were successful in their enrolled math course, then in that case, we would say that there was a 72% success rate. So the trick or the question really is, well, what do we do when we have a probability already determined, and it's always going to be kind of independent in, for the number of times that might be tried. So, for example, we look at this distribution that was predetermined for the flip of a coin 3 different times, of which we have the respective probabilities here. In a previous video, I showed how we can find basically the mean and the standard deviation, of which in any case, we put the list 1 for the random variables, and we put the list 2 for the assigned probability, and then we hit enter. So it's telling me 1.5, and it's telling me that the standard deviation is 0.866, which means that 0.866 squared would give us the variance of 0.75, for example. And that's just telling us the spread of the data, for example. So note that we could find the probability respectively because, for example, we know how many times is a coin tossed for that probability distribution. Well, it's 3 times. What is the probability of success? Well, a half. So if we do this, we get 1.5. which is the exact same thing as the mean that was determined by the calculator. But if we take, for instance, the square root of 3 times a half, but then multiplied by the complement of our probability, which in this case would be 1 minus 0.5, then in that case, this will give us a standard deviation of 0.866. Well, you need the variance? No problem, 0.75.